Well, I've still got access to the webcam. I'm gonna try a quick video here on just an introduction to Newton's method. So Newton's method is a way of finding roots of a polynomial. Roots is another word for zero. So solving where is a function equal to zero, solving that equation when the roots aren't nice, when it's a hard equation to solve. So essentially what you do is you pick a number that's a nice number that you think could be close to the solution, but it's not. It's not the solution, because the solution is usually going to be an irrational number. And what you do is you find the tangent line to the curve at that point. So you find, because the equations of tangent lines are things that are relatively easy for us to find. Well, now that's just a line. The line you can easily solve for where the line is equal to zero. You set it equal to zero and isolate the x. And the zero of that tangent line, notice, is closer to the root than our original guess was. Rinse and repeat. Now find the tangent line to this new x value. So come up and now find, I kind of flubbed up the tangent line on that one. It should probably be a little bit steeper, but so now find the equation of the tangent line to that new x value. And then same thing, solve where it hits the x-axis. Every time you do this, in most cases, every time you solve for the new x-intercept of that tangent line, it's going to get closer and closer and closer to the root that you're actually looking for. So algebraically, what you're doing is you're picking a first approximation that we'll call x1, first approximate answer, and then you're finding the tangent line to the curve at that point. Okay, so the equation, so then find the tangent line at x1. Okay, so the equation of a tangent line is y minus y1 equals the slope times x minus x1. But we know a few things here. We know that y1 is going to be f of 1. This point right here, sorry, f of x1. To get the y, you just plug in the x. So this is f of x1 equals, we know to find the slope. The slope of the tangent line is the derivative evaluated at x1, right? And then times x minus 1. So there's the equation of this tangent line here in blue. Now, then we want to find the x-intercept. So now we want to find the x-intercept of this line. Well, you find the x-intercept by setting y equal to 0. So we plug in 0 for this y right here. All right. And then when you plug in 0 for the y, the x value, the new x value here, is going to be this x2 that we're looking for. Okay, so if you now solve this for x2, and you don't have to go through this step, I'm just showing you where the formula comes from. If you solve this for x2, so let's see, this is, let's go ahead and just divide both sides by the derivative. So we get negative f of x1 divided by f prime of x1 equals x2 minus x1. Add x1 over to the other side. And we get that next guess, sorry, I'm going to slide it up here. That next guess, the next x-intercept that's closer to the root that we're looking for, x2, is equal to x1, our first guess, minus f of x1, which is the original y value of the first point that we chose, divided by f prime of x1, which is the slope of the first tangent line that we found. So that in general, x of n plus 1, the next best iteration, the next best x-intercept, is the previous guess minus the y value of the previous guess divided by the slope of the tangent line of the previous guess. And that's where Newton's formula comes from.